Having known what is refactoring, let us look at why do we need it. In case of a TDD development, in case of extreme programming, the development has become rapid iteration. Now, due to rapid iteration, this is a basically prototype model of developing the software. So at any given point of time, what you are doing is you are given a set of requirements. From that, you break down to a smaller requirement. You start building your software product using the smaller requirements first. And the moment that implementation is done, you then release the code. So with this kind of an approach towards software development, it's very often we see that our requirements also tend to change, because we would have written today the code for a certain requirement. Tomorrow with some other requirement comes in when we are implementing, we figure out that maybe one of the functionality that we have already implemented probably needs to be extended a bit, or some things has to be removed from it and things like that. So our requirements keep changing. So whenever the requirements change, we have to go for refactoring, which means that to accommodate the changed requirements, we have to do the refactoring. Usually with the TDD development, design also keeps changing because it's an evolving process. So each design change actually results in a refactoring. And the third point, which is also more important, is that in a lot of times, in a hurry to complete our work, over a period of time, we also end up doing some amount of bad coding or other. A lot of times things are hard coded, or some of the dead code is left alone there, and things like that, which needs to be cleaned up. So now that we know what is refactoring and why it is needed, let us look into how do we identify what part of the code needs a refactoring. Now, when you have a piece of code and you want to try to find out what is to refactor, some of the points that you can look for are, one is look for a code that is hard to understand. Now, hard to understand code usually means that we have written some difficult logic or some very complicated logic where it is most likely not needed. This thing happens typically when you're in a hurry and you're trying to fix things in a hurry. Second point that you could look for is look for a repeated code. Looking for repeated code, it's also a common thing, especially with web applications or applications where there is a layered approach is taken for code writing. So let's say you are dealing with multiple types of objects in your software system, and that objects have to be stored into a database. Now, such cases, the actual part of the code that opens a connection and writes it to the database and gets back, that is common actually. So a lot of places we end up writing the code in such a way that a lot of it can actually be put it in single code, and probably through use of generics or maybe by using an inheritance, we could easily have reduced the number of code drastically, number of lines of code drastically. So that is one more pointer. Third pointer is look for a dead code. Now, dead code is a code that is lying there in your source code file, but it's not really being used. Now, why does it happen? It usually happens due to as a result of refactoring also, because there are times when as part of refactoring you have done away with a certain code, or you just changed a code where and in one method, and as a result of that some other part of the code that this particular method was using is no longer needed, and you probably just forget to remove that code. So such code you can look for. Then the next one is look for variable names or method names that do not tell you what they are being used for. In Java, it is usually preferred that you write the variable name in such a way that you are even able to look at it and tell it what is the data type of that variable, which actually will help you greatly when you are coding. Similarly, for methods also, method name should clearly and precisely tell you exactly what functionality it is doing. Then the next point is look for long methods. Now, long methods are also are actually very difficult to understand. Now that is one of the bigger problems with long methods. Optimum size for a method probably should be 8 to 10 lines, probably 12 lines in Java, because Java usually you might be doing some amount of exception handling and things like that. So the number of lines of code might be slightly higher, but 12 to 15 lines code, probably 20 lines is good enough. I mean, it should not go beyond that. Anything that is too much of a code is happening, just look into this code, see what is it that you can extract out and create another code and method and put it into another method. See if there is any reusability you can bring into it, because more often than not, lengthy code also gives you a chance to not just break it into different methods, but also to probably slight rejig in the design so that you can get a reusability concept over there. The next point is look for large classes. But one of the things that you have to keep in mind is that identifying what needs a change or what needs refactoring is very subjective. It is subjective from developer to developer. It is also kind of depends on the circumstances or the state of the project that you are in. It depends on the experience of the developer, what they are looking for. Sometimes you might be hard pressed for time, but also at the same time you just want to fix only a certain things so that you are addressing a only particular issue, and other things you can choose to live with for a slightly longer period of time. So this is all in all, refactoring is a subjective matter for developers. So with that, we conclude this particular segment where we identified as to how do you identify what needs the refactoring.